In section 5.3 we're going to continue to look at linear equations, but while we've been looking at them in slope-intercept form, now we're going to switch gears a little bit and look at what's called point-slope form. So what does this look like? Well, you're going to see an equation in this form. Y minus y1 is equal to m times parentheses x minus x1. And if you look at that x1 and the y1, these are going to give you the coordinates of a point that's on the line itself. So x1, y1 is a point on the line. Oops. And of course, m is our slope. So in this form, you already have the coordinates of one point and you have the slope of the line, hence the name point slope. So what does this actually look like with numbers? Well, notice that the y and the x will still appear in your equation, but the y1, the m, and the x1 are all replaced by values. So here we have y minus 5 is equal to 3 times x minus 1. So the point on the line, and also notice that the subtraction is built right into the equation. And this is going to cause a little bit of a flip-flop in a sense of your signs for the coordinates. So when you see this x minus 1, the 1 is actually a positive x coordinate, and y minus 5 means that our y coordinate is actually a positive 5. So it looks a little bit counterintuitive perhaps. And then of course the slope is 3. Now notice in the next one we have y minus 4 is equal to negative 2 times x plus 9. So that plus 9 really you could think of as x minus negative 9, which shows us that the x coordinate of our point is negative 9. So again, it seems like a bit of a flip-flop. Instead of a positive here, which you would think from an addition, it's actually a negative, as opposed to our y coordinate, which is still positive. So we have negative 9, 4 is on the line, and our slope is negative 2. Alright, let's look at a few example problems here. So number 1, write an equation in point-slope form of the line that passes through the point negative 1, 1 and has a slope of 4. So remember, our form looks like this. Y minus y1 is equal to m x minus x1, and we're going to substitute for x1, y1, and our slope. So here this is x1, y1. So with y1 being positive, we're going to have y minus 1 is equal to, our slope is 4, and then x minus, and x1 is negative, so if we want for now we can write minus negative 1, but of course what that will really generally be written as is y minus 1 equals 4x plus 1. So again, notice the change in sign. A negative coordinate actually gives us an addition, and a positive coordinate actually shows up as subtraction. Number 2, write an equation in point-slope form of the line that passes through the points negative 4, 1 and 2, 13. And notice that in this case, we're not given the slope, which means we need to calculate it. So we're going to use that formula we have from several sections ago. Slope is equal to y2 minus y1 over x2 minus x1. And again, it doesn't matter which one we call point 1, which one we call point 2. Let's go ahead and call the first one point 1, second one point 2. So now if we look at the difference in the y coordinates, we have 13 minus 1. So 13 minus 1 goes in our numerator. And then for the x coordinates, 2 minus negative 4 in our denominator. So 2 minus negative 4 will give us 13 minus 1 is 12. And then 2 minus negative 4 is 6, and 12 over 6 simplifies to 2. So now that we have our slope, we need the coordinates of one point. Notice that we have two different points to choose from, which means we have two different ways that we can write this equation, and it really doesn't matter which one you use, which one you pick. So we could take y minus 1 is equal to our slope of 2, and then x minus negative 4, in other words, x plus 4. Or you could also write y minus 13 is equal to, same slope, 2, x minus 2. And these turn out to be equivalent equations, and it doesn't matter which one you pick. And you don't need to write both, you only need to write one. Okay, number 3. The function f of x equals 30 plus 10 x minus 5 represents the cost in dollars of ordering x paperbacks from a book club. Describe the function in terms of how much each book costs. And it might help you to see, first of all, remember that f of x is similar to saying y, and this is almost in point-slope form. So if we were to rewrite this, let me write it again as it appears. F of x is equal to 30 plus 10 times x minus 5. If we were to rewrite this by subtracting 30 from each side, then it's going to look like point-slope form. So we have f of x minus 30 is equal to 10 x minus 5. And now this is in point-slope form. So we have a point at 5:30, and we have a slope of 10. And what that tells us is 5 is our input, that's going to be the number of books, 30 is the output, so at this point, if you buy 5 books, your cost will be $30. So we can say 5 books will cost $30. And then the slope gives us our rate of change. So that tells us that each additional book, so once you go past 5, each additional book costs that rate of change of $10. Okay, so this appears to be one of those deals where right off the bat you buy 5 books right away, you pay $30, and then each time you buy another book, it'll be $10 more. Okay, number 4, an online journal raises its subscription price by $3 per year each year. After 6 years in existence, its subscription price is $53. Write an equation in point-slope form that models the cost of the subscription as a function of how many years the journal has been published. So if we look at, let's say C is going to be the cost of a subscription, and let's say T is the time in years of how long this journal has been in business, and then we have M is our rate of change, which is $3 per year. Now we can set this up where we have our given point, where we have time is equal to 6 years, and the subscription price is $53. So we're going through the point 653 with a slope of 3. And what that gives us then is C is our cost, that's our output. It depends on the amount of time that the journal has been in business. So we're going to have C minus the cost at this point, 53, is equal to our slope of 3. And then T, our input, how many years this has been going on, minus our given value here of 6. And there's our equation. C minus 53 is equal to 3 times T minus 6. So if you want to determine how much is this going to cost after 10 years, you would substitute 10 for T and go ahead and evaluate and calculate C. Okay, number 5. And this is a case where point slope can be very nice, very convenient for graphing. So we want to graph the equation y plus 3 equals 2 times x plus 1. So if we look at the point that's on the line, this is, remember, represents -1 for our x coordinate, -3 for the y-coordinate. And the slope is equal to 2. So we can plot that point, -1, -3. So from the origin, -1, -3. And then a slope of 2, remember we could write if we want as 2 over 1. So from this point, we can either go up 2 and to the right 1, or we could have also gone down 2 and to the left 1. So remember, positive over a positive is positive. Also a negative over a negative is positive. So we're going to go through these points, oops, and this is where it's nice to have a straight edge, of course, and you'll have something like this. Alright, and finally, tell whether the data in the table can be modeled by a linear equation. Explain. If possible, write an equation in point-slope form that relates y and x. So let's look at the idea again of slope or rate of change, where we have the difference in our y values, y2 minus y1, over the difference in our x values, x2 minus x1. So we can look at what is the difference in our x values here. Going from 2 to 4, we went up by 2. And then from our second point to our third point, we go up by 2 again. And be careful with this, because this isn't always going to work out that the input or the x values increase by the same amount each time. So we need to look at each successive pair of values here. So now our change in y, going from 10 to 4, we're going down by 6. From 4 to -2, going down by 6. -2 to -8, going down by 6. And -8 to -14, going down by 6. So we have a constant rate of change. -6 over 2, -6 over 2, -6 over 2, -6 over 2. So our slope is equal to -6 over 2, or in other words, -3. So yes, this is linear. Linear because the rate of change is constant. So rate of change, or remember that's the same thing as slope, is constant. And a constant rate of change means this is linear. And then we have our slope. Now we have to pick a point. And it doesn't matter which one you pick. So for example, if we look at this, remember we have an ordered pair here of x and y. So we look at these pairs. We could have used 4, 4, or 6, -2, or 8, -8, or 10, -14. Any of those pairs. So if we pick that first ordered pair, we would have y minus 10 is equal to our slope of -3 times x minus 2. Or we could have said y minus 4 is equal to our slope of -3 times x minus 4, if we had used that second point. Or ... In other words, we could have used any one of these. If, for example, if we get to the end here, we could have used the 10 -14, and that would give us y plus 14 equal to -3 x minus 10. So here's a case you could have actually had 5 different answers, and all 5 of them would have been correct as long as you have the right slope and you use one of the ordered pairs here, any one of the 5. So good luck. I hope you enjoy point slope form, and I hope that you see there are some occasions where it's actually a rather convenient form to use. Enjoy.